Thank you, Meredith. And so we've heard a lot about how great robotics are, and I think the next question from our audience is actually a perfect segue. And this is from Mary Kay, and it's for Gary, but of course everyone is welcome to answer afterwards. And the question is, are there any other ways to teach STEM besides robots? I've tried to understand how to program robots and just don't get it. I feel doomed. Gary, this one's for you.
Absolutely. Yeah, and you don't necessarily, for STEM education, do you need coding? You don't necessarily need coding or programming. It's an option. And a lot of what I would say with that is I can tell you, there's so many computer languages out there, and I don't necessarily need to learn all those things myself. A lot of those things, you just put it in front of the kids, and they will pick it up themselves. I can tell you a lot of my students, their coding techniques are probably better than mine. So the coding you don't need, and there's really, I wouldn't, robots, what's good about them, like I said, is it's easy to get the kids, it gets kids excited, but there's plenty of other things that you can do that will get the kids excited, whether it's rockets or taking a frog apart, dissecting, or what have you. There is really, yes, technology is great, and computers are great, but the one thing to not lose sight of is there is one trend to just go 100% virtual with no manipulatives and nothing that's hands-on. And I would really, unless like for some safety concerns or something, I would stay away from it. I think getting the kids' hands dirty, the kids don't get enough chances to do things with their hands, whether it's kitchen chemistry or playing with some small animals or what have you. I think there's so much to do, and really it's just taking the guts to say, yes, the kids are going to get their hands dirty.
I'm going to jump in here too. I think the first thing to say is, one, to be kind to yourself. This is a lot to learn, and I think sometimes the professional development and the courses that we currently have, they don't provide enough support, right? This takes time to learn. We know that in the workplace, right, people will learn things for several months. So the first one is, if you are interested, right, find that right program that's a good match for you. And I think we're going to see more and more of those come online. Maybe you don't want to learn just from tutorials. You want to be actually enrolled in a program. And I think the second piece that I wanted to respond to is, yes, there are tons of other ways to do STEM, and maybe start with your passions. We're running a program right now called Novel Engineering, which integrates engineering and literacy. So teachers are connecting designing things to books they're using in their classroom, right? So imagine Tales of a Fourth Grade Nothing, right? A little boy in New York who has a pesky little brother who's always getting into your stuff, and making Peter, the main character in that book, your client, and starting to design things to protect his turtle, to keep a little brother out of his room, right? You can start with really, really simple craft materials, and as you get comfortable in that space, right, thinking about adding on and doing more things. So there's definitely lots of different ways to go.
Yeah, and if I could add one more thing, when Gary was talking, it triggered an idea. We ran a program where we were carving mini pumpkins, and we were adding our Arduino kit to it to have the jaws open and close with sensors, and I just thought that would be so great. And the thing that I learned right away was the kids were amazing at the robotic part, the coding, the Arduino, and the sensors. But what I did not take into account was how many kids have never carved a pumpkin. And so getting back to Gary's concept, there's so many amazing tools on computers and technology and devices, and all that stuff is great, and I love it. But we have overlooked the amount of opportunities kids actually have to do hands-on. You know, kids aren't outside playing, exploring like they used to. There's other safety concerns and issues. And so for me, I had to take a whole step back and actually teach kids how to use a pumpkin carving knife, and actually how do you actually take a Sharpie on a pumpkin to draw the design. And I'm just thinking, like, I just thought that was just common sense, and it wasn't. However, they could easily have the servo motor open and close and trigger and make noise like that. They didn't think twice about that. And so I think sometimes don't overlook the base knowledge of what do we really need for these kids to grow and do these things. You know, and even talking about robots, it could be other things. We did a 7th grade language arts project where we built 3 tiny homes, a language arts class, but STEM more so than anything. So even though they were reading the math, the engineering to actually build a sustainable structure, you know, the technology to have a green space, and the science to make sure that it was a livable space, that it could pass code, and it could be a living space for someone if they need it to be. And so sometimes I think we have to, you know, open up our horizons and really expand. You know, as much as I love robots and I get in that tunnel vision, is to say there's so much more when we start talking about science and technology and engineering and math. It's everywhere. Look at the problems going on in the world, and 9 times out of 10, it's probably a STEM problem that you could bring to your classroom and have kids try to solve.